So for today's class, we're actually going to spend time reviewing regression. So it seems like there's some more questions about regression, and I'm happy to take more and more time understanding why we're doing regression, and how to get the regression parameters, and what are the economics that we get out of regression models. One thing that I want to start off with is to really encourage you to spend some time on the posted readings. So people are looking up, and you really need to spend some time on those readings. You need to understand them, and if there's any sentence that you don't get in those readings, you need to come talk to me in my office. Okay, so come talk to me. I spent some time making these readings. I know some of these ideas are difficult. A lot of them, though, if you spend just a few minutes thinking about them and look at the readings, you'll get 90% of it. There are 10%. If you don't get it, you can come and talk with me, and we'll get everything cleared up. So basically, the readings that I posted that I've made, they contain the entire lecture. They contain everything that I want you to understand. And I know that people are busy with a variety of things, with recruiting trips and interviews about your time, but you can get a lot of bang for your buck in this class if you spend time on those readings. Yes, Stephanie?
I wanted to ask, do you have any time to plug out Fridays, like tomorrow, to
Yeah.
go over things? When are you in your office?
I'm in my office, so tomorrow and then all day.
Pretty much all day?
Yeah, so just send me an email, look at your schedule, send me an email, and set up an appointment. Yeah. So, but before you come to my office, I want you guys to spend a couple hours on reading the posted readings. So those are going to help you a lot. And that will enable us to do a lot more in this class. There's a lot of really cool stuff that I'd like to get in this class that I find fascinating, that I hope that we can get to. And it just depends on how quickly you can get through your stuff. All right, so let's just review regression. We're going to review what we talked about last time, and then we're going to extend what we talked about last time to some other stuff. All right, so why do we want to estimate this thing right here? Why is that important? Why do we care about that? The conditional expectation. First of all, what does that mean? Yep.
What the return on that stock or that first one is going to be, given that the portfolio does this.
Yep, that's what it means. It means what we expect it to do, right?
And we want to know that so we can pick up insurance securities for our portfolio.
That's one big reason. That's the primary reason why we want to estimate this thing. We have a portfolio of stocks. We want to know, for various levels of the portfolio, how is this stock going to perform? Okay. So when the stock goes down, as Nathan said, if we expect this number to be high for negative values of X, then we can think of this stock as insurance. We expect it to pay off high in times when our portfolio is tanking. Okay? So it's like insurance. It pays off high when our portfolio is down. We expect this to be high. Yeah, Stephanie?
And the reason why we like this better than just like the little probability square is because it creates a function that we can plug in
Yes.
the stock.
Yes.
Stock expected return, so
Yep.
that we can
Yes.
don't have to, like, I guess, recalculate it every time with a different probability.
That is a great question. So we're going to use the parameters. We're going to use this as a number, or the parameter. So what we're going to do is we're going to develop a. First of all, what we did last time is we developed a model to represent this. Okay. And to answer your question, we're going to use the parameters of this model to feed into other models that we're going to build. We can't take a joint PDF and shove it into a model very easily. But we can take these specific parameters and put them into models that will dictate how we should trade. Okay, so we need to understand what these mean and how to get them. Okay, so first of all, this is just a model. So it's not the only model that we could assume. that would give us this. We want this equation to represent this for any given value of the portfolio. You can think of other models we might use here, nonlinear models or whatever. This right here is a simple model. It's linear. It only contains, x in this linear term here. It tends to work pretty well in practice, and it also is consistent with a lot of economic theory that we're going to develop. And so that's why, for right now at least, we are going to treat ourselves to the simple linear model. It's not perfect. Okay, no model is 100% perfect, but it does a pretty good job as a model for this. So why do we want to use a model to represent this? Well, because in reality, we don't go around to the analysts estimating joint PDFs. Okay? That's not what we do as analysts. The purpose of joint PDFs is to give us intuition for what these numbers mean. Okay? That's why joint PDFs are on the CFA exam. Because they want to make sure that chartered financial analysts don't think of these as just a black box. They actually understand what these parameters mean. And that's why we use joint PDFs to understand what do these numbers mean. Okay? So, but then in reality what we do is we use samples of data from joint PDFs. We don't observe the joint PDF, but we observe outcomes. We observe historical data. And once we know what these parameters mean, using the joint PDF and how to get them, then we can use those methods to go to the data and estimate these things using a sample of data. Okay, so first of all, Nathan said one reason why we are interested in this right here is because we want to know to what degree does a stock act like insurance. Okay, what has to be, if this is going to be considered insurance or a hedge for my portfolio, what has to be true?
It has to be positive when given this name.
What has to be true about the different parameters here?
The slope.
Your B, yeah, so it's insurance if your slope is less than 0, right? So if B is negative, then when X is negative, a negative times negative is a positive number. Is everything okay with that?
Yeah, I just can't see it.
Oh, we can't see it because it's right like this. Okay. If B is negative, then what that means is that when X is negative, then because when we multiply two negatives, we get a positive number. If B is negative, then when X is negative, we expect the stock return to be very, very high, right? So this is the key feature of insurance. If B is very positive and high, then you can think of this as kind of the opposite of insurance. Think of a contract that makes you lose money right when you get in a car crash. Right? That's really not the kind of security that you really want to hold, right? It causes you to lose more money right when everything else is crashing. Okay, that would be an example of security with a positive beta. All right. One other reason to see why stocks with low or negative betas are helpful is because they help ensure, or they help reduce volatility. That's kind of strange to think about. How can you incorporate a risky security into your portfolio, and the net result be that it reduces volatility? Well, the reason is because it moves opposite to your portfolio. When your portfolio is down, it pulls it up. When your portfolio is up, it pulls it down. And so the net effect is that when you conclude the security to your portfolio, because it moves opposite to your portfolio in general, it helps get rid of volatility. Okay, so that's why we like those kinds of securities. All right, so what we did in class last time is we said we can, if we have a joint PDF, it's pretty easy to find our regression, intercept, and slope just by solving the two equations of the two unknowns. That should be pretty straightforward. That should also help you understand what these numbers mean. Okay? But then we said, well, look, it turns out if we use our stat rule number 3, that our slope is just the covariance between our explanatory variable, in this case RP, and our dependent variable, divided by the variance of the dependent variable. Okay? And our intercept is equal to expected y, our dependent variable, stock return, minus b times expected x, said, hey, look, if we find these parameters from the joint PDF, we get the same answers as we do when we solve the two equations and the two unknowns. Nice thing about this approach here, about that number and that approach there, is that we know how to estimate these things using data. It gives us a method to take to the data. So we've justified it using the joint PDF. We first find these parameters using the joint PDF, the two equations, the two unknowns. Should be reasonable and intuitive. But then we also find these parameters using stat rule 3, and it gives the same answers. But we know how to estimate these things using data. We know how to use the covariance function and so forth. Some students have said that the harder way, of course, with the joint PDF is this approach here. Okay, how do we find these numbers here? If you go, let me scroll this down. You go to the website. And you click on regression.xls. Click on the PDF tab. So here's the example from the reading, okay, from Facebook and some arbitrary portfolio. So up there at the top left, we have the PDF. In the reading, you'll walk through step by step how to find your regression, intercept, and slope using the two equations and the two unknowns. In this example here, we find our regression beta and intercept using stat rule number 3. Okay. So if you're having a hard time finding the regression, intercept, and slope using stat rule number 3, you can come to this example here. Of course, the regression slope is just the covariance. Oh, you can enable the editing here. The regression slope is just the covariance divided by the variance of your portfolio. So it shows you exactly how to calculate those terms from the joint PDF. The intercept is just your expected dependent variable minus b times expected explanatory variable. So it's just that. So the spreadsheet starts from basic principles, and you can use this as an example. In fact, you could, I think, the way things are set up, you could just change the numbers here and get the homework done. If that's what you want to do, just change the numbers for the PDF, and everything will carry through. But that helps. I mean, that will enable you to get the problem done. But you need to understand how to get these parameters on your own as well. Okay, so, and again, if any of these are, you're like, I'm not quite sure what you're doing here. Why are you doing this? You should come to my office and talk to me, or talk with the TAs, talk with Chase. He knows what's going on. All right, so here's an example to find that from the joint PDF. All right, so as I said, in reality, we don't have a joint PDF. We just have a sample. And let's go ahead and draw a sample of returns from a joint PDF, and let's draw a picture of it. Some people like to look at graphs and pictures rather than equations, and so let's draw a picture of this sample here. Okay, so here's our sample. Here's return on the portfolio. It's our explanatory variable. And the return for the stock, we'll call it stock I. That's the dependent variable in this example. Because, so the conditional expected return for stock I depends on the return for the portfolio in here. We're trying to explain, we're trying to understand the conditional expectation for the stock given the portfolio return. This is our dependent variable. This is our explanatory variable. All right, so this right here is just a picture of that regression. That's all that line means. Okay, so this right here is a picture of this line. It has an intercept, it has a slope. Okay, and so that's all that this line means, the picture of the conditional expectation. Okay. So let's suppose that in some month, return for the portfolio was 10%. Okay, let's go ahead and understand what this is saying here. What that says is that, well, given that the portfolio returns 10% in a given month, I expect the stock return to be that right there. Say it's 12%. Okay. That's what I would expect. Usually in years when the portfolio returns 10%, in those years generally I expect the stock to return about 12%, is what that is saying. And I get that straight from this line, after I get my A and my B. Well, it turns out that the stock that same year actually returned, say, 18%. Okay, so there was something else that happened to the stock return. So generally I expect the stock to return 12% in these kinds of years, but in this year it actually returned 18%. This is called the error term, and we get a lot of economics out of the error term. Understand what the error term is and its properties. You get a lot of really interesting economics out of just that simple parameter there. Okay? Think of the error term as the leftovers. So every month we observe some return for stock I. If we subtract off the conditional expectation for stock I, given the return, so I'm going to use the subscript T. Return for the portfolio in T, that is the error term in that period T. That's that distance there, that vertical distance. Total return, this would be my 18%. This is my conditional expectation. This is the 12%. So in this example here, the error term is 6%, so 0.06. So the error term is just the leftovers, but it turns out that the leftovers give us a lot of economics. It's interesting. Okay. So last time we talked about two properties of the error term that once we understand what the properties are, I can show you that you get a lot of interesting economics out of the error term. So the first property is that the average error term is always equal to 0. So to understand why that is true, let's draw some pictures. So suppose that I have my sample, and it's obvious why that must be true. So here's an example where it's not true. You can say that doesn't fit the dots at all. The average error term from that 0. What's the sign of the error term in that example there? Positive. So they're actually all, so the error term is that number minus that number there. So it's negative, right? So this is like, so in this case, the error terms are all negative. So when we're down here, they would be all positive errors. When the errors have an average of 0, then we get a line that looks like it makes sense. It's right down the middle, about half are above, half are below. The second property of error terms that helps us get a lot of economics is the idea that the covariance between our x variable and the error term is always 0. The error term represents the component of the stock return that is independent, has nothing to do with whatever is our x variable. Now you could, in general, you could pick whatever x variable you want to explain stock returns. You could pick GDP growth, you could pick interest rates. We're going to use portfolio returns to try to explain variation in the stock return. But because of this property right here, the error term will represent variation in the stock return that is completely independent of the x variable, of the portfolio return that we pick. And we get a lot of economics out of that. To understand why that is true, let's suppose we have our scatter plot here, and we have a line that looks something like that. Okay, so you're like, well, it's like that. I'd like to tilt it more towards that way, in the clockwise direction, right? It should be obvious. And what you're saying, basically, by saying that, is that this is not true, that the covariance between your x's and your errors is not 0. Let's see why that is. So here for low values of x, when x is negative, what's the sign of our error terms? They're positive. So for low x, we have positive errors. For high x, what's the next sign of our error? They're negative. So we have low values of x, we have positive high error terms. And for high values of x, we get negative error terms, low. So they're moving in the opposite direction, right? The covariance between our error term and our x is negative. This is not true. So when you're saying the line doesn't fit, you need to tilt it in a clockwise direction. That means that the covariance between our error terms and our x variable is some negative number. It's not 0. Okay, so what we like is to tilt this in a clockwise direction. Okay, so it's like that. And then we say, well, yeah, for low values of x we have some positive, some negative error terms. For high values of x we have some positive, some negative error terms. It doesn't matter where you are on the x. It doesn't really have anything to do with the sign of the error term. The covariance is 0. So for low values of x, some are positive, some are negative. For high, some are positive or negative. They are independent. Their covariance is 0. All right, so that's the second important property we want to understand from our error terms. All right, so we talked about this model. We have some understanding when we regress a stock onto, so we say we run a regression, those terms that we use, or we regress a stock onto a portfolio, those are terms that we use. So we know this is true. The total stock return at any period is equal to the conditional expectation plus the leftovers. Okay? And we know the leftovers here, they're mean 0, and they are independent of the portfolio return. If someone asked you, what does the beta mean? How would you explain that in like 1 or 2 sentences? If you were on exam, tell me in 1 sentence, what does the portfolio beta tell us about the stock? How would you explain that? What does that mean? What does that mean relative to something like this? Here's the terminal portfolio. Here's the stock return. What are those different? So here we have a positive slope, a negative slope. Yeah, Taylor.
So does the beta measure how sensitive stock is to the portfolio?
Yeah. Right. So there's this portfolio return changes every period, right? Driven by news about the stocks in the portfolio. And this beta measures how sensitive the stock is to that specific kind of news. Okay, so if the beta is 0, that means the stock is not very sensitive to this kind of news. It's high and positive, it's very sensitive to this news. If it's negative, it means that good news for the portfolio is bad news for the stock. Yeah, Michael?
It's kind of like duration, kind of like interest rates and stocks, or bonds.
In some sense, yeah. So the longer the duration, the more interest rate sensitive you are. Yeah, it's similar. Okay. Well, one thing that we haven't talked about yet is what does this mean? What does the intercept mean? So the once again, just to summarize, the beta measures how sensitive the stock is to news about the portfolio. It also tells us to what degree the stock may act as insurance in this portfolio. Okay, that's another piece of information we get from the stock beta. As you said at the start of class, the beta is negative, it's kind of like insurance. What does this intercept mean? Well, it turns out that when your x variable is the total return for the portfolio, this doesn't mean very much. You don't get a lot of good economics out of the intercept. Okay. Students want to say, oh, well, that's the risk-free rate, or that should be 0, or that should be some other value. Well, in this regression model, it doesn't mean very much. But we can get a lot of economics out of our model if we make a simple modification to our regression. This is where this is kind of the main thing we want to focus on for the rest of the day. So let's talk about a modified regression model. Okay. So our dependent variable is going to equal the stock return, and that's no change from before. So that's the same thing. So our dependent variable, our y variable, is still going to be the stock return. However, our explanatory variable is going to equal the return on the portfolio every period minus its mean. That's going to be where we have our change. So we're going to have a sample of returns for the stock a sample of returns for the portfolio, and we're going to subtract off every period the mean return for the portfolio. That's the only change we're going to make. How does this affect our parameters? How does that enable us to get some economics out of our regression? This is our y variable, and this is our x variable. I'm going to refer to this as SP, shock to the portfolio. You can think of this as the unanticipated portfolio return every period. This is an estimate of the expected return for the portfolio each period. So suppose this is like 6%. Well, suppose we actually got a return some month of 8%. There was an extra 2% that we got that month that we didn't expect. There's some shock, some unanticipated news that caused the portfolio return to be higher than we generally expect. You can think of this as a shock to the portfolio, something that's unanticipated that we didn't expect ex ante. All right, so let's then look at the parameters of our regression. We're going to have a regression, so y equals a plus bx, okay, plus e, our error. Our y is going to be our dependent variable, the total return for the stock. We have some intercept that we're going to interpret now. We're going to have the regression slope and times our x variable, which is now the shock to the portfolio return. Then we're going to have some residual. So every period in our sample, we're going to be able to decompose the return every period into these three pieces here. What are these three pieces every period in our sample? Okay. Well, let's think about first the regression slope. Stat rule 3 says this is the covariance between our x variable and our y variable, which is the return of the stock, divided by the variance of the x variable. Okay. Turns out that is the same thing as our portfolio beta, a stock I on P. Nothing has changed. This is the same as before. So modifying a regression model in this way does not change the slope. You get identically the same answer. How about our intercept? So I put hats here because these are our estimates. Okay, so our intercept now is going to be our average y variable minus our portfolio beta times our average x variable. Our x variable here is the shock to the portfolio. Actually, again from stat rule 3. All right, so what is our average x variable? What is if we do this, we have a column of numbers, and we subtract off the mean from every number. We first find the mean of the numbers, and then we subtract off the mean from every number. We find the mean of that column of numbers. What do you think that mean is going to be? Any thoughts on that? So we have a column of numbers, 6, 3, 5. Subtract off the mean of these numbers. We find the average of that. So it's going to be 0 every time. So it's like, you can think of this as the average of this. This is just going to be x bar minus x bar. The average shock is going to be 0. The average of this is going to be 0. Meaning that investors generally get what they expect. On average, the shock to the portfolio is 0. Their expectations are unbiased. Okay, so we'll see this in just an example in just a second. But your average shock is always going to be 0. This is mean 0, so this part drops out. This is then equal to the average stock return, which is an estimate of our unconditional expected return for the stock. So suddenly now our intercept makes sense. It's something very specific. In this regression, where our x variable is the shock to the portfolio, and our y variable is the total return for the stock, our intercept becomes the average stock return, or in other words, an estimate of the unconditional expectation. Okay. Let's plug in, so we can write this equation right over here, y equals a plus bx plus e, which is true for any x and y, for any regression model. We know that our y variable is the total return for the stock. Our intercept is an estimate of the unconditional expectation for the stock. Okay, that's that piece right there. This right here is our portfolio beta times the shock to the portfolio in that period. Okay. So here we have a shock to the portfolio multiplied by the portfolio beta. This right here represents a shock, something that is unanticipated, to stock I that is related to portfolio P. Okay, so we get, for every period, we get what we expect plus this shock right here. What do I mean by this? A shock to stock I, something that's unanticipated, that is related to portfolio P. Let's give you an example. Suppose that stock I is returned for Autoliv. Autoliv is manufacture airbags and car parts. And let's suppose that these portfolio stocks is a portfolio of auto stocks in Michigan. All right, so if the shock right here is positive, this portfolio stocks, there must have been some unanticipated good news about these auto stocks in Michigan. For example, Consumer Reports just announced rising demand for U.S. cars. Great news for auto stocks in the U.S. Their stock price for that month jumps up, and the return is higher than it generally is for that month. How does that affect Autoliv? Well, it depends on how sensitive Autoliv is to those kinds of shocks. You expect if this was a portfolio of auto manufacturing stocks, that base probably something very high and positive. Good news for the auto stocks is also translates into good news for Autoliv, right? So this is that something that happened that month to Autoliv that was unanticipated, but that was related to the firms in the dependent variable, in the portfolio, right here. Okay. All right, that's not all that happened. We've got this last piece here. Well, the last piece is just the leftovers. We find this because we know how to estimate our A and our B using stat rule 3. We observe a given return for the portfolio in a given month, observe its shock for that month, put that into there. We can observe the stock return that month. We can estimate this just using the average, because we observe everything. The last piece here is just the leftovers for that month. Okay, so to define this, just take this number here for that month, and subtract off this piece here. That's the leftovers. Well, the leftovers you might think is not that interesting, but there's a lot of interesting economics here as well. For one thing, we also know this is mean zero, because it is an error term in this regression. So it is mean zero. It's a shock. It's something that is unanticipated. Okay, it's on average zero, which means we can interpret it as a shock, something that is unanticipated. However, we also know that the covariance between our x's and our e's is also equal to 0 in any regression. In this regression, our x variable is the shock to the portfolio. We know that the covariance between E and SP is also equal to 0. It always is for any regression. So then we think, well, this is then, it's some shock, something extra that we got that month we didn't expect, okay? But it is unrelated to what happened to the portfolio of firms. This is a shock to stock I that is unrelated to the firms in the portfolio. Okay? Let's give you, yeah. Suppose that Autoliv has a big plant up in Ogden. All the car manufacturing stocks are in Michigan. Suppose Governor Herbert says, we're going to lower taxes for all companies in Utah. That's great news for Autoliv, right? Suddenly they're going to have more revenues to pay out and to shareholders in the form of dividend. So that would be good news for Autoliv, but wouldn't affect this portfolio of stocks because they're in Michigan, right? It's something that happened to Autoliv that is unrelated to the firms in that portfolio. Or it could be something that's more, so that kind of a shock, the tax reduction shock, would affect all firms in Utah, but would not affect these firms because we're assuming that those are car stocks in Michigan. This also could be something that's more firm specific. It could be something like Autoliv just acquired a new patent for a new sweet airbag that's going to make it a lot of money. Well, that's great for Autoliv, but may not affect the car stocks in Michigan. Or it might be that the CFO for Autoliv was just caught for fraud. Oh man, that's bad news for Autoliv, but shouldn't affect the stocks in the car stocks in Michigan, right? So this is just something that was unanticipated that affected the return for Autoliv that month that is unrelated to the firms in the portfolio. Okay. So let's do some examples then.
Just a quick question.
Yes.
Is the only way to calculate that after getting everything else?
Yes, you must estimate your A and your B. And your A here, of course, is going to be the expected stock return. So you get everything else first, and then you just subtract the two. That's the only way you can do it. Okay, let's do some examples then. So first of all, keep this regression, keep this equation here in your mind. So here's what we've done with our regression. So we're just running a regression. We pick a y, we pick an x, and for any y in our x, this equality is true. Okay, the total dependent variable any period is equal to the intercept plus beta x plus our error term. Just so happens that when we run the regression in this way, where our y is the total return for the stock, and our x is the explanatory variable for the shock to the portfolio, that we get a lot of economics for each piece of the regression. The total return is what we expect plus two kinds of shocks. The first shock is something that was unanticipated that affected the firms in the portfolio. This is how that shock affects Autoliv, plus something else that was unanticipated that also affected Autoliv, but is independent of the shock to the portfolio. Before I give an example, let me draw a picture of this real quick. So, is the camera catching this stuff over here? So let's draw a picture of this equation right here. So pictures are helpful for some people. So on the x-axis here we have the shock to the portfolio. When the shock to the portfolio is 0, that means the portfolio returned what we expect. Okay. As we go out over here, we get a positive shock to the portfolio. Over here we get a negative shock to the portfolio. And our y variable is going to be the return on stock I, which we're saying in this example is return on Autoliv. So we get a sample here of data, how the stock, we plot the sample here for shocks and the return on Autoliv. We fit the regression line. Okay, so our average error term is 0. And the covariance between our error terms and SP is 0. For low values of SP, we have some positive, some negative error terms. For high values of SP, we have some positive, some negative error terms. So again, the covariance between our error term and SP is 0. So now what we can do, we can say, well, we know that this line right here is just a picture of this regression. This is the intercept. This right here is the expected return for Autoliv, expected return for stock I. Okay. So we might think about why was the return for Autoliv so high, say in this month, January of 2008. Well, this is the amount we would generally expect the return to be every month. Well, there's something that we did expect. There's something here, a lot here that we didn't expect that was not anticipated. So the two kinds of shocks are shocks that are related to the portfolio and shocks that are unrelated to the portfolio. If we go right here, A plus BX, okay, that'll take us right here on the regression line. Okay, so from here to here, that represents the shock to Autoliv that is related to the portfolio. That's so this whole distance here is intercept plus this. That's that piece right there. We go right to that line. It's A plus BX. See, our X right here is the shock to the portfolio in that month. Here's our A. We take A plus B times X, and we get to this point right there. But there's something else that happened. Of course, this is the leftovers. This is our error term. That's the shock to auto leave that is unrelated to the firms in the portfolio. Stephanie, do you have a question?
No, I'm just trying
Can you
to,
absorb it?
yeah, get in my mind.
Okay. Next we have just these 1, 2, 3 pieces. So we have this outcome for the return in that month, say it's 18%. So we can decompose the return into 3 different pieces here. So we got these 3 pieces by running a regression, where the X variable is the shock to the portfolio, and the Y variable is the total return for auto-leave. In this regression, the intercept is the expected return for auto-leave. We get that far. And then if we do A plus BX, that's just the equation for this line here. Plug in a specific value for X into this equation, A plus BX. And we're going to get to that point on the line. So for that value of X, we plug in there. That gets us right there. Well, of course, this first part here is just the part that was expected. The second part here is just the B times our X variable. Okay, so beta times SP, the shock that is related to firms in the portfolio. And the last part is the leftovers, the error term, the component of the stock return that period that is independent of firms in the portfolio. Yeah.
Okay, so a change to the entire portfolio, then that changes the entire slope, because that's the A plus BX part.
Yeah, so
Because without that change, it would have been a completely different line entirely, right?
So what we do is we have to first estimate these things for a variety of outcomes for this. So we estimate, we observe a sample, and we first estimate what that is, and then we hold that fixed.
Okay.
Once we estimate it, that stays fixed. And then we consider different values of shocks and see how that will affect our return.
Along that line.
Exactly.
And then any difference, either positive or negative from that is just the
The E, yep. If you're above the line, it's a positive E, below it's negative. Yep, and the economics of that is that these are shocks to the stock return that are unrelated to the portfolio. So suppose auto leave returned a high return in one period, and your boss asks you, why do you think that happened? Why did auto leave return 24% last month? What you could do is you could decompose it into these parts. You could say, well, turns out that if you observe a very high value for this component of the shock, this gives you some clues about where to start looking for answers. If that was big, you would say, well, it turns out that Ford and GM, they had some positive news, and that also appears to have affected auto leave. Or if that's small, and this part is big, then your conclusion that you should be looking for something that's unrelated to the firms in the portfolio. Those are the kinds of shocks that should be trying to explain in my answer to that question. Okay? Let's do some examples. You have a question, Stephanie?
So from what you were saying, can you work this backwards then?
Okay, so how would you work it backwards?
Well, just what you were saying, like if you had a certain return, you could divide it out.
Yep. So we could do it backwards. We could say, wow, in March,
We had that tax increase.
yeah, so we had the tax break in March. And so all firms in Utah went up, okay? That would affect
So
this.
how do you quantify that? Like if I'm in a company and I'm like, oh, we had, our taxes went down in March.
Uh-huh.
So how do I say, oh, how much did that affect my return?
Yeah, so we're not going to get exact, precise numbers here for that kind of thing. All we're going to say here is that in this model, there was something that was unrelated to the portfolio that affected
So
the
it's not
stock
going to
return.
be zero.
Yeah. On average, it's zero, but
On average, it's zero, but because we
Yeah.
know that something happened.
if you wanted to be more specific, you could include more explanatory variables in your regression. If you wanted to hone in on a more specific cause for the high stock return, like you could put in a portfolio of stocks that are located in Utah. And you could put in a portfolio of stocks that...
So you could try to look at other quantified numbers.
Yes, yes, exactly.
See how much they were affected.
If you wanted to hone it down even more specifically, you could include more than one variable here as your x. And that's what you can do. Okay, so let's do some examples. So keep that equation in your mind. I'm going to ask you to use that equation there. Okay. So this last spreadsheet here, this is data zero mean. So what I have done here on the spreadsheet, column B is a sample of returns for Autoleaf. Okay? Column C are returns for an arbitrary portfolio. So here you can see that, for example, in March of 2009, Autoleaf returned about 25% in a single month. It's pretty good. In April 2009, Autoleaf returned 33%. So those are pretty high returns. And for now, we're going to include one explanatory variable in our regressions. Just understand how much of that was driven by news about this single portfolio and how much was driven by news that is unrelated to firms in the portfolio. Now, Stephanie, that's a great question, and you could include more than one X in your regression if you wanted to be more specific. But we're going to get a lot of traction just by looking at one explanatory variable. Okay, so the first thing that I do here is I create column D. This is the modified regression model. So what I do for column D is I just subtract off the mean portfolio return every month. So cell H15, keep that in your mind. It says average portfolio return because that's what that is. I just take the average of all of these numbers in column C. That's that number right there. Subtract it off every month. So this represents the unanticipated component of the portfolio return every month. So for example, in April of 2009, I generally expect the portfolio to return about 1.6% per month. But in January of 2009, or in April of 2009, actually I had 10.2% return. There was something unanticipated, and I got an extra 8% above what I was expecting for the portfolio. So I do that. Now in cell G7, here's where I estimate my intercept and slope for the regression, where B is my dependent variable, Autoleaf is my dependent variable, my Y, and column D is my X. So in this cell here, I just use stat rule 3. So I just take the average Y minus my B. Well, actually, let's start with B first. You can't get your intercept until you get your slope first. So your slope here is just the covariance. I use the covar function between my X and my Y, divided by the variance of my X. That's just stat rule 3 to get my slope. Okay, any questions about that? Okay, and then once I have my B, I can get my intercept, my average Y minus my B times my average X, just by the equations of stat rule 3. Now it's important to know those equations because they help us get some economics, help us understand some of the economics behind this model here. But Excel makes things pretty easy. There's a function called intercept, and you just type equals intercept. Excel says, give me your known Y's and your known X's. My Y is column B, my X is going to be column D here. So when I do that, I get the same answer for my intercept. Let's look at my slope. So Excel has a function called slope. It says, give me your known Y's and your known X's. My Y's are column B, and my X's are column D. Okay, and that gives me also my slope. So this is my intercept. This is my portfolio beta. Okay. Yeah, Michael.
Real quick, I'm a little confused on the variable. The auto leave, that is the X variable.
That is the
response
y variable. So we're
Dependent variable.
it's the dependent variable, right?
And
So
the portfolio is the Y.
so my y, this is my x right here, the shock to the portfolio. So we're trying to find the conditional expectation for auto leave given the return on the portfolio. Remember, so think about the insurance analogy. We want to know, does auto leave tend to move with the portfolio when the portfolio goes down? Do we expect auto leave to go down or to go up? So we want to explain variation in auto leave given the return for the portfolio. That's generally what we're going to be doing. There's going to be some security on the left as the y variable, some portfolio as the explanatory variable. All right, so now what we argued is that the intercept now in this modified regression is going to be the average stock return for auto leave. Right? That's how we get. So this intercept now is equal to average of column B. Let's go ahead and check that. That's true. So yep, it is. So if I take just the average of my auto leave returns, same thing as the intercept. So in this regression, so here's a picture of the regression line right here. The x variable is the shock to the portfolio. The y variable is going to be the return on auto leave, and the intercept is my expected return, 3.1%. That's that number right there. Okay. All right, and so let's now go ahead and decompose some returns. Okay. So for example, in July of 2009, Autoleave posted a 25% return, about a 24% return. How much of that was due to a high expected return for Autoleave? How much of that is due to unanticipated shocks? Shocks that are related to the portfolio and shocks that are independent of the portfolio. Well, we know that the expected return is just our intercept. So let's put that right there. Intercept. Okay, so that's that piece. So we're trying to come up with three numbers that will sum up to that thing right there. Is our objective. How do we find? So now this return is what we expect plus these two kinds of shocks that we wrote here on the board. The first shock was the shock that is related to news about the portfolio. How do we find that? How do we find the shock to news about the portfolio?
Isn't that
Yeah.
the beta?
It's the beta times the shock to the portfolio. So the portfolio actually had a positive shock too in that same month. We expect the portfolio to give us 1.6% per month, but in that same month the portfolio gave us 7.7%. So there's some good news about the portfolio that same month. In fact, the unanticipated component, the shock to the portfolio was about 6.1%. How did that affect Autoleave? We got to take into account how sensitive Autoleave is to these kinds of shocks. So we take that shock there and multiply it by the portfolio beta. So this is the expected return. The next one is going to be the shock that is related to the portfolio. Okay, so we take our beta, portfolio beta, multiply it by the shock to the portfolio that month, so about 14%. So 14% of this good return for Autoleave is actually related to news about the overall portfolio. There's some good news that affected the portfolio that also affected Autoleave. Caused it to be up above its mean by an extra 14%. Yeah.
Shouldn't it be D9 instead of C9?
Yes, thank you. Yeah, thank you very much. Yeah, so that is our X. That's right. So it's actually only about 12%. Okay. Now what we can do is we can get the leftovers, the shock that is unrelated to news about the portfolio. So how do we find that? The leftovers?
Not just the difference.
Just the difference, yeah. So it's that minus that minus that. There's whatever is left over. Okay, so we get that. And that is the error term, that is the shock to auto leave that is unrelated to the portfolio term. Okay. So what I'm going to do now, so by construction, these sum up to that thing there. Okay. And let's go ahead and erase the labels. We'll erase that label here, and we're going to paste these on down. Let's just go ahead and paste these down to the other, oh, whoops. 4. Paste these down to there. Got to absolute reference this, so I want portfolio times I8 to absolute reference that. So we can find that component every period. And an absolute reference, E9 is okay, E9. So that none of those should be absolute referenced, right? Because we're just going to subtract those all the way down. So we're going to just paste those all the way down. Okay. Let's go ahead and paste them up too. As we said, this right here is the error term of our regression. We've given some economic interpretation, and we have claimed that the error term has these certain properties. One is mean zero. Second, it has a zero covariance with our x variable. Let's go ahead and check that those are true. So let's just do it up over here where we see everything else. I'll do it right here. So first of all, in this cell, so average E. Give me a funky little sign there. That's okay. Equals average of my error terms. Okay, so my average error term is 0. So that one student said, well, that's not really 0. It's pretty dang close to 0. Right? It's as close as you can get. You got 0.000. You got 0.00000, 18 zeros, and then a 7 after 18 zeros. That's what that minus E, the 18 minus E, E minus 18 means. We have a point and then 18 zeros. That's very, very close to 0. And now let's check the covariance between our x's and our e's. Covariance between our x's and our errors. And are these really independent? And sure enough, yep, those are also independent, so we're in good shape. So that just tells us that, yes, we really can interpret this number here as something that affected the component of auto leave that is independent of shocks to the portfolio. So it's some other kind of shock that didn't affect this portfolio here. All right. So in this example, we've been talking about this portfolio as being a portfolio of car manufacturing stocks. So we know that this error term is independent of news to these portfolio of car manufacturing stocks. Can we necessarily interpret this as specific just to auto leave? Think about that question. We know it's independent of shocks to this portfolio of car manufacturing stocks. Is it necessarily something that just affected auto leave? Could it have affected other stocks, do you think? So once again, think of the example of the lower taxes. So these lower taxes affect all stocks in Utah, but may not affect stocks in Michigan, right? So this is independent. This is something that happened to auto leave that's independent of this portfolio. But if this portfolio is some small subset of firms, for example, a collection of car manufacturing stocks, we can't necessarily interpret this as firm-specific.
Sorry, this is sort of a backstepping question, but you said that for the average, the 7.86, because of the E, that's really close to 0?
Uh-huh. Yeah, so this is, actually what that means is this is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, okay. Algebra 18,
17, 18, 7, 8, 6, 4, and so on.
Okay.
That's what that means. Yep. That's what that E means. Yep. All right. So, but now think about if this portfolio happens to be the portfolio of the entire market. We put every stock that trades on any exchange into this portfolio here. This is the component then of auto leaves returned every period. is independent to this entire universe of stocks, of all stocks. In that case, we generally interpret this number right here as being firm-specific, just to Autoliv, because it's independent of this portfolio that contains all stocks. So if this were like the portfolio of all stocks, the entire market, then this must be driven by a new specific just to Autoliv. For example, it got a new patent, or someone in its hierarchy was put in jail, or there's something specific about Autoliv that just affected it and not other firms. So again, if this is some arbitrary portfolio, all we know is that this is just the component of Autoliv's return that's independent of this portfolio, which may or may not be firm-specific. But if this is the market, then we generally interpret this as being a firm-specific shock.
Yeah, and so you're just saying that if that was a portfolio, let's say for just the markets in Michigan,
Yeah.
then we could put in other variables to try
Yeah.
to narrow down
We actually-
what was actually specific to the company.
Yes, exactly. So we could also add on as a variable a portfolio of stocks in Utah, or we might include interest rates or GDP growth or other variables that might affect the stock return until we get down more and more narrowly to the firm-specific part. But generally, when this is the market portfolio, we generally go ahead and interpret this right here as being something firm-specific. Because this is the portfolio of all firms in the U.S. This is independent of that, so this is the firm-specific shock. Okay, let's do some examples then. Some other examples. Oh, and so in the homework, it uses these terms systematic and unsystematic shocks. And systematic means, so when this is the market portfolio, we call these systematic shocks. Okay, so it's just a matter of terms. When this is the market portfolio, we call these systematic shocks. When it's the market portfolio, we call these unsystematic, idiosyncratic, or firm-specific. So those are terms that you should be aware of. Yep.
Just to review a little bit, for column F, so that's the shock that's related to the portfolio. So you took the beta and you times it by the X and
Yep, we took the beta, we multiplied it by the shock to the portfolio in that month.
you find the beta by doing stat row trees. Okay, and then the error, how did you get the error?
It's just the leftovers.
Just the leftover.
Yep, so here we have expected return.
And see your,
So these three numbers here must add up every period to the total return for Autoliv every month. So we find these two things here,
yeah.
and then we just take the difference.
So it's E.
So it's B3 minus E minus F. It's just the difference there. So once again, if this is the market portfolio, we call these systematic shocks, and we call these unsystematic, idiosyncratic, or firm-specific. Yeah. So that's in the reading.
Column E, what was it for that?
Column E. This is just expected return. It's the intercept of this regression, or the average return for Autoliv. Okay. Okay, so here's our regression example. Let S denote a portfolio of supermarket stocks. So it's not the market portfolio. It's a small subset of stocks, Kroger, Safeway, Walmart. Assume the portfolio beta of interstate bakeries, whose brand names include Dolly Madison and Butternut, is 0.90. Return on the portfolio for August 2014 is found to be 2.2%. While the return on interstate bakeries was found to be 4% over the same month. The expected return for the portfolio is 1.6%, and expected monthly return for Interstate Bakeries is 1.8%. Why did Interstate Bakeries outperform expectations in August of 2014? Decompose the shock into news related to supermarket stocks, which are Interstate's major clients, and news unrelated to supermarket stocks. And then it says, can we necessarily interpret the latter as news that is firm specific to Interstate Bakeries? Why or why not? All right, so we're trying to explain this high return for Interstate Bakeries for August of 2014. We got a 4% return. Okay, so we're going to have three pieces to this return. It's going to equal to what we expect it to be, plus these two kinds of shocks. Okay? So we expected it to return, Interstate Bakeries is 1.8%, so 0.018. Okay, so that's the expected return.
Can you move that up a little bit?
Yep. Now we're going to add the shock that is caused by news related to supermarket stocks. Let's find the shock to the portfolio. So for the portfolio, we actually got, let's see, portfolio was 2.2%. But we expected the portfolio to be 0.016. So that represents the unanticipated component of the portfolio return. So this is equal to 0.006.
Sorry, could you SP the 0.022? Where did that come from?
So this is the return for the portfolio that month. Okay. And this is what we expect. So this is the return on the portfolio minus the expected return on the portfolio for that month. So this represents the surprise that the market received that month. We expected the return generally to be about 1.6%, but that month they actually got 2.2%. This is the shock to the portfolio for that month. So it's 60 basis points. Okay, so there's some positive news about supermarket stocks. You might expect that kind of news to also influence Interstate because Safeway and Walmart are the clients of Interstate. How does this shock, how much did this shock influence Interstate Bakeries? How do we find that?
Times by the beta.
Times it by the beta. Thank you very much, Nathan. Yep, so the beta is 0.9, that is given in this example. We multiply it by 0.006. That's the influence that this good news to supermarket stocks has on Interstate Bakeries. There's one last piece. What do we?
The difference.
The leftover, right? Leftover stuff. So we just take that minus all of that stuff there. And that is going to be 0.0166. So this is in your reading as well. So this right here, so this is the outcome for our X variable, the shock to the portfolio for that month. This is the error term for that month. We know that those two things are independent. Hence we interpret this piece right here as the shock to Interstate Bakeries that is related to supermarket stocks. And this right here is the shock to Interstate that is unrelated to news about supermarket stocks. All right?
Where did you get the 0.016?
It's just the leftovers. It's the
0.04 minus 0.018 minus that. Right.
Yep, so it's that minus that. It's just whatever it needs to be to make these two things equal. Okay, so that's that. So that's how
So
it
you
comes.
just like plug in.
Yeah.
So
Yep.
like is everything you have like an X there. That makes sense.
Okay. So can we interpret so that we know that this right here was a shock that is independent of supermarket stocks? Can we interpret that as being firm specific?
Yes.
Well, is this the market portfolio of all stocks? It's not. Therefore, that we don't necessarily interpret that as being firm specific. All we know is that something that happened Interstate that is unrelated to this specific small portfolio of stocks, which could be something that affected all stocks in Utah, for example.
Oh, okay. So it's not necessarily from specific.
If that's not the market portfolio, which is not this example, then that may or may not be firm-specific driven. If that's the market portfolio, then we say, well, that's probably something more, something that's like firm-specific, because that's the portfolio of all stocks.
And it will usually say in the problem, like, this is a market.
Yes.
It's a broad market
Portfolio, or is it portfolio
So
of...
then you can assume that the E or the error term is the firm specific.
Yep, you have the market as your predatory variable. One last thing that I need to explain to you before we go, so one last quick thing that will help you on the homework. Excel offers a regression package that gives us a little bit more information. Let me show you how to do this and what information we get. The only extra thing that we get from running this in Excel is we get both our estimates of the parameters, plus we get a 95% confidence interval for the parameters. Okay? So let's just see how you do that. You go to data analysis, and you pick regression. You click on OK. You say, okay, it's asked you for some y's, so give me some y's. We'll give you column B for the y's, the dependent variable. For your x's, we're going to use the shocks to the portfolio, column D. Okay, and then it just says, where do you want to put this output? You put it somewhere here on the spreadsheet. This is also all in the reading that is posted. It walks you through this process step by step. The only thing we really care about from this output is this bottom table here. What we get right here is the regression intercept and slope. Those two numbers there are the same as these numbers up here, 0.0316 and 1.866. Those two numbers there. Under coefficients, there's our intercept. Here's our slope. Then over here on the far right, we get the 95% confidence interval for our estimates. So these are our intervals. And we're going to later find it useful to be able to test the null hypothesis that our true parameters are 0. It's actually going to be the key thing to do to determine if you can have found a viable trading strategy to beat the market. You need to test whether your parameters you estimated are actually 0. So let's just show you how to do this real quick. You look at the interval. 0 is not in the interval. It's not in that range. So you can be 95% confident that the true intercept right here is not equal to 0. These estimates here are prone to sampling error. But what this says right here is that we can be 95% sure that this true parameter is not 0 because 0 is not in the interval here. Same thing for the regression slope. So on your homework problem, there's one quick question to ask you to do that. Just pull up this output in Excel, examine the 95% confidence intervals. If 0 is in the interval, then you can't reject the null hypothesis that these two things are 0. If 0 is not in the interval, then you can be 95% confident that the true parameters are not 0. And it talks about that in the reading as well. All right, we'll stop there for today. And